in Algebra 2, Lesson 122. Part A is the laws of logarithms. And you're saying, logarithms, you're saying, wait, didn't we already study the laws of logarithms? Yes, we did. Here's a fun fact. Back in, what was it, lesson 1, laws of logarithms? John did not lay them out. He waited until this lesson, 122, to actually lay out the logarithms. I knew that and think that's ridiculous. Information, 2 lessons or 3 lessons, whatever it was, after you actually asked students to use it. So I went ahead and taught it. So now all I'm going to do is draw the chart so that it sinks in your mind. I'm going to ask you to grab paper and pencil if you don't have it right now and draw along with me. And half a page is good. If you need to go get your paper and pencil, pause me. Okay, so we've drawn the rules for exponents a lot of times. And the first 2 columns of the chart are the part we've already drawn. We write product, quotient, and power. This side, good girl, Grace, it's okay. This is the rules for exponent side. This is the part we know. Product means you're multiplying the bases and you add the exponents. Quotient is you're dividing the bases. Whoops. You subtract the exponents. That looks confusing, but you know x is the base, those are the exponents. And if you've got one base raised to a power, you want to raise it to a higher power, that is when you multiply the exponents. That's a dot. Okay? Those we know. Those are the rules for exponents. We've been doing that. Well, you guys didn't do Algebra 1 with me, but we have been doing it ever since then. And now we're going to take those and flip them ever so slightly into the laws of logarithms. All right, so the first one says, if you're multiplying this number, the argument, you can break it out. Let's put a base of b in there. Okay, so if you're multiplying in a single argument, you can break it out and add the 2 logs. Okay, that's kind of like this one. If you're multiplying, then you add. So multiplication and addition go together. And then we know what happens with this one. If you're dividing, then you subtract. Okay, and remember that for all of these, you can use them in either direction. We very often switch the direction with the logarithms. This one we tend, well, I think the way the problems have been set up so far, we tend to move from the right side to the left using these. With the rules for exponents, we tend to move from this side to that side. But the bottom line is you can go either way. And then this last one is the hardest, it's the more difficult one to see how it relates to the rules for exponents. Give me a second. But it's the most fun to use. If you've got a power on your argument, you can just hop it down and put it in front of this, meaning that you're multiplying the whole thing by that. This one translates in the weirdest way to me. But yeah, I guess it makes sense because here you're raising it to the power just like here, and then you multiply, and that's what we're doing here is multiplying. Okay, so there are how to use these. This is information you've already seen. We're just reviewing. On to lesson B. Intersection. Of sets. All right, let's say that we have two sets of numbers. Set A is the numbers 1, 2, 3, 6, and 7. Set B is 1, 3, 8, 9. Okay? And we want to find that. What is that symbol? That symbol means intersection. I remember being taught this concept in 2nd grade, and I remember that this shape looked like the N in intersection. Later we're going to have another one that we can keep track of in a regular way. So we're looking for the intersection. We're looking for the place where these two sets overlap, right? Like an intersection of streets is the place where they share the same space. We're looking for the place where they share the same numbers. So the intersection of sets A and B, we just compare the members and we see it's 1 and 3, right? Those are the numbers that are in both sets. Oh, that's pretty easy. All right, that actual problem, here's the actual problem, I'll flip. Example 122.1, we've got set P, which is 1, 2, 3, 4, 7, 9, 13. You would not have to copy these down for the homework. I'm just doing it so we can look at them. And this is 2, 5, 7, 8, 10, 13, 15. Just double checking to make sure I wrote them correctly. Again, you could just look at these sets in your book, these sets of numbers, and we're supposed to find the intersection of sets P and K. And we write it within the little sets notation. So we're looking for overlap. All right, we just compare them. 2, 3, 4, 5, that doesn't work. 7, 8, 9, 10, 13. There we have it, right? 2, 7, and 13. That is not changing the world too much for you guys, is it? That's so simple. All right, part C is the union of sets. All right, I'm going to go straight into the problem. I'm not going to do the preamble. 122.2. We're going to use these two sets again, P and K. So I'm going to write given P sets, P and K, find, aha, what does that mean? That means, and notice how this gives us the U shape of union. All right, so by union what we mean is list everybody all together. So we would say the union of sets, whoops, I put the little tail on it, it shouldn't have that, it's just the rounded part, right? The union of sets P and K, 1, 2, 3, 4, there's that up there, then we come down and get the 5, there's no 6, but there's 7, 8, 9, 10, there's no 12, and there's no 11, 13, 15. And I compare to the answer in the book to make sure I didn't leave anything out. 7, 8, 9. Oh, I was wrong. There isn't a 10. Oh. That's weird. In the book, John changed set K in this example so that 10 is no longer in it. I used the very same sets. up here. So this is correct, but in the book, it's not part of the answer. So John and I are both right. He just changed the members of this set K, and I did not. I left them the same. Okay? So you get it. You just make sure that every single one of these numbers is represented there. Okay, last topic. So that's intersection and union, right? And we use this little trick to remember. The union means everything all together, and that's the upside down. And intersection means the part that they share, and that's that way. All right, last bit talks about Venn diagrams. You've probably seen these. This is part D. It's called a Venn diagram. I assume Venn was the name of the dude that did it. And they look like this. They're two overlapping circles. So this would be this is set K. This part intersection of the two sets. If I put dots all over both circles, that would be the union. And then there's space out here for things that are neither P or K, right? So book, I don't want to copy all this. Okay, so you can see here we've got a Venn diagram, one circle, two circles. I better put my cap on my pen or I'm going to end up writing in the book. Okay, there's two circles. There's set A and B. That's really hard to see, but there's the A and there's the B. So we're looking at the numbers, and John wants us to find well, here's the intersection of A and B. It's just the two numbers they both share, so that's 15 and 17. And then the union would be all the numbers in either circle. So there's 6, 7, 8, 9, 10 and 11 are outside. There's 13, 14, 15, there's 16 in A, 17, and then it skips up to 20, 21, 22, 23. Okay, right? You got it? Now let's look at this one. The circles contain the members of sets A, B, and C as indicated. Designate the areas that represent. Okay, this one I'm going to draw in the book. I want you to see the way the picture looks. So there's the picture. I'm going to copy that, and then we're going to find these three areas. This is kind of fun because it's a total art project. All right, I'll make it big so you guys can see easily. So we have A, B, and C. Pretend the circles are perfect. They're not. Okay, this is A, this is B, and this is C. So, John wants us to find first, I'm going to use some different colors. The place where A intersects with B. Okay, there's A, there's B, here's where they connect, but we don't want this little bit because that, no we do, because that is the intersection of A and B. It's all of this, right? This also includes C, but that's okay. We're looking for the intersection of A and B. Fabulous, we found it. Okay, the next thing we want in a different color is the union of sets B and C. Okay, so let's do that with dots. The union, so this we want all of B and include this overlapping business. So there's all of B and then all of C. Okay, so when we do intersections, we're focused on the overlaps. When we do unions, we're focused on the whole circles. Okay, can you see it? This is fun because you get to make that look really cute. Okay, so let's have the chicken pox. And then the last one. C, we want B's intersection with C. Okay, so B and C, we want the intersection, so that is going to include that little tip of a point right there, as well as all of this, right? Intersections. Focus on the overlap. Unions. Focus on the full circle. I think this whole concept is pretty intuitive, but there are a couple of rules to help you through it. And then let's see if we pulled it off. There's A and B, union of B and C, and then the intersection of B and C. This was intersection also. All right? So for your practice, you get to do ooh, that's a funky looking picture. It's different than the simple one we used. All right? That is example 122. Yay! Goodbye.